Chapter 13, Section 5, The Scientific Revolution. How did discoveries in science lead to a new way of thinking for Europeans? Explain how new discoveries in astronomy changed the way people viewed the universe. Understand the new scientific method and how it developed, and then analyze the contribution that Newton and other scientists made to the scientific revolution. So, again, when they use this word revolution, they're not using it lightly. So it's a radical change or shift in direction. And so when we look at the Renaissance and the Reformation, those two things are really coming together, where they are challenging the ways of thinking and the things that had kind of been in place for centuries. These things that people took as articles of faith in some ways, where they didn't even doubt Plato and Aristotle and Ptolemy, and they just accepted those things as that's the way they were. And then when you have the Renaissance and the Reformation, it causes people to begin to question many things around them, and all of a sudden it opens up the world of possibility that maybe everything we thought we knew we didn't know. And so that's what's really going to happen here. And so when we look at Copernicus, Copernicus is, and the other thing, to be honest with you, the tools that are available are more advanced. And so the observations that they're able to make are more advanced. And so suddenly they realize that they are seeing things that don't fit the model. And Copernicus is the first one to really do that. And sooner or later he realizes that the universe isn't geocentric, it's not Earth-centered, it's heliocentric, it's sun-centered. And not only is the Earth revolving around the sun, but there's other planets. And so this is kind of tough for many people to digest. It removes the Earth and man from a special place in the universe. But the other thing it does is it really challenges these Greek and Roman writers and teachers and scientists and philosophers, and it throws the European world for a loop a little bit. But you get Brahe and Kepler, who do some more observations and say Copernicus is right, and so they have data to back it up. Galileo is a scientist who, again, also studies all these things and says not only are there more planets, but there are planets that have moons that revolve around them. And he did that with Jupiter and the moons of Jupiter. And this is really freaking people out. And the church isn't ready for this kind of radical change. And they make him recant. They use the Inquisition, probably under torture or threat of torture. Galileo says, oops, I screwed up. But there's some debate about how genuine that is. But he spends the rest of his life under house arrest. So that's how threatened people are by this. So when we go further, sooner or later the scientific method gets developed, a way of being able to test ideas. And so you've got Bacon, who is really kind of the father of the scientific method. He thinks that you need to understand truth, and the way to do that is through observation and experimentation, and that's the best way to understand what's going on. For Descartes, Descartes is a philosopher, and he kind of doubts his own existence, and he uses that to prove his existence. Because I doubt and because I think, that proves I am. And so it's through this internal dialogue where he kind of discovers what truth is. And so sooner or later, this step-by-step process that we know as the scientific method gets formed. Ask a question, create an experiment, observe, analyze the data, crunch the numbers, and then decide, well, did I actually find what I set out to find? Did I actually create an experiment that experimented for what it was that I was looking for? And if I did, what did the results tell me? And then where do I go from here? And that's a leaping off point for a new question. So when we look through breakthroughs in medicine and science, I mean, there's all kinds of things going on. And so if you look through this, you've got Vesalius, who's drawing the human anatomy. You've got Pare, who is creating this ointment that deals with infections, but he's also playing around with prosthetics. Harvey is diagramming the circulatory system. Leeuwenhoek is perfecting a microscope so he can see small things blown up. You've got Robert Boyle, who's developing chemistry and looking at elements versus compounds and the basic parts of matter. So all kinds of things are going on at this time. And probably the big wig is Sir Isaac Newton, being able to link all of these sciences together, but also through this defining and describing gravity. What he does is he's able to say that the universe and nature operate under certain mathematical rules and laws, and that we as humans are capable of figuring those things out and understanding those things. And that's going to put the world on a whole new trajectory in a lot of ways, because now from Sir Isaac Newton, we're going to go into the Enlightenment, and the Enlightenment thinks that these natural laws apply to all things, and that we can use these natural laws to create a more perfect society. And in a lot of ways, the Enlightenment and Sir Isaac Newton's ideas are going to inspire the founding fathers of the United States to try and form a more perfect union. And so this is going to have big impact and big waves down the road.